Hello guys, welcome back. In this video, let us learn about one more important topics or few more important topics on AWS. That is data lake and data warehouse. So before moving to that, so let's move from need scenario. Let's say if we run a company, if we are running a company, we may get data from different sources, right? Yes. The source may be we got data from transaction data, right? Yes, we may got data from transaction data, or we may get we may get data from business applications, right? Yes. From business applications, I may get data of business application data, and we may get this data from IoT devices also. From that, we may get IoT devices data, and we are using mobile phones, right? Yes. So for mobile phone applications, for my company, if I am having any mobile phone applications for my company, then do mobile phones provide you mobile phone applications data? Yes. Even my company is maintaining some social media account, then do it get social media data also? Yes, it may get social media data also. So like this, from various places I am getting the data for my company. Now we want to place we want to place we want to place this data to store somewhere, right? Yes. So for storing this data, we have two options. In order to understand which type of data, either data lake or data warehouse do I need to use for my best need, so we need to compare them at first. So I have told you, right? So there are two types of storings we have, that is data lake, data warehouse. So let's compare them. So based on type of data we can able to store under data lake and under data warehouse, let us compare them. In data lake, we can able to store any type of data. We can able to store schemaless data, and we can able to store specific schema related data. That means if a data is having specific schema, that type of data also we can able to store under data lakes. That means if you have some data with some particular structure of it, then if we want to store that data, this data lake allows you to store that data as well. If there is some data, like for transaction we are adding few more columns, sometimes we're adding some messages in between, right? Yeah. So during that time, that comes under unstructured data, or else you can say schemaless data. Those type of data also we can store under data lake. Coming to this data warehouse, very important major difference, we can able to store only schema data, that is structured data only we can able to store under this data warehouse. So let us write that as well. Structured data only, schema full or structured data, specific schema full data or structured data only we can able to store under this data warehouse, right? Yes. So coming to here, we can able to store under data lake, we can able to store schema less or schema full data also. That means unstructured or structured data or semi-structured data. Any type of data we can able to store. Example, like structured structured data, unstructured data. Unstructured data we can able to store, as well as semi-structured data also we can able to store under this data lake, right? Yeah. So if we want to analyze this data with some real-time example, so just for assumption purpose, I'm providing this example. If you want, you can assume this data lake. You can assume this. You can assume data stored under data lake will be like stones under your lake. You can see lakes. Yes. So in our places we can see lakes. So there, how the stones will be? Some stones will be structured, some stones will be unstructured, they will be in random positions. So some stones will be semi-structured. Half of the stones will be structured and half of the stones will be unstructured. We combine them both, then we can see them as semi-structured stones. So like that, if we are having data in place of stones, then we call that as data lake. So let us analyze this also with some real-time example just for assumption purpose. You can assume how the rocks will be constructed in your building. They must be structured in a specific format, right? Yes. So you can assume this data warehouse in that way. All your data will be arranged in a structured, some specific structured format. Stones in your house, you can assume that as data warehouse. Stones in river or lake or ocean, you can assume that as data lake. In place of stones, you can assume that data. So when do we use this data lake and when do we use this data warehouses? For analytical purpose, we use this data lake to store a large amount of data. For analysis, we need to use this data lake, right? Yeah. So to store any type of data or any size of data, any amount of data, we use this data lake because it costs you less for storing that much amount of large data compared to the data warehouse. Compared to data warehouse, storing that much amount of structured or unstructured data under your data lake will cost you less. Let's say you stored 10 TB of data, 10 TB of structured data in data warehouse, and you stored 10 TB of unstructured data in data lake. You will be charged very less under data lake compared to the data warehouse. So that's why in order to store very large amount of data, we use this data lake. Then why do we use this? We use this for storing large data only, but we store our data mainly for processing. So to process some particular data, let's say I having in my company, I'm having a lot of data coming from these all. Now what I'm expecting is I am expecting to process my data which is coming from mobile applications. In that case, what I need to do, you need to pick that particular data and move it to data warehouse, and then there you can able to analyze your data in structured format. You can able to move it to data warehouse, and then there you can able to analyze your data and you get some results from that analysis, right? Yeah. So in this way, for storing your normal data will be charged less, and if you want to analyze that data, then you can store that particular specific data in specific structured format under your data warehouse, and you can able to analyze that data, right? Yes. So now let's see one more important point of this data lake. So why I need to choose this data lake? So what are the good capabilities do we have if I choose this data lake? So basically, if any data lake is having the following 6 conditions, if any data lake can able to provide the following 6, you can see them: storage, data movement, data catalog and discovery, analytical processing, and prediction analysis. So if any data lake is having these 5 properties, then we can say that data lake as good data lake. So actually it's 5, not 6. So if any data lake is having the 5 following, then we can say that data lake is a good data lake. So what are those 5? Storage, data movement, data catalog, analytical processing, and prediction analysis. So let's see one by one in detail. This storage is nothing but your data lake itself. So what is the service that you use it for storing your data? We call actually that storage as data lake, right? Yes. So what is this storage? Does it can able to maintain structured, unstructured, and semi-structured data unlimitedly or not? So, that also one more important point. This data lake can hold unlimited amount of data, whereas this data warehouse can hold up to limit amount of data. If you see an example of data warehouse, you have Redshift in AWS services that can able to hold up to petabytes of data. You can even able to store up to exabytes of data in this data warehouse. Whereas if you comes under example of data lake in AWS services, there is S3 is there, where it can able to store unlimited amount of data, that is up to, so how much amount of the data that you store, that this data movement, specifies how your data is moved into data lake. So that we need to specify under this data movement. So that we're gonna discuss under this. So under the third section, that is data catalog and discovery, here we actually find, so whatever the data we have, in the data we will find and categorize that data belongs to which field that data, that is we gonna find metadata of particular data, so that it can be easily identifiable by whatever the person who are coming to your company next employee. And after that, we can do analytical processing on our data. So in order to sense our data, in order to process our data and get the data, since we are processing here general data, we can call this as generic analysis. What we can call this as generic analysis. So this is the last one, that is a prediction analysis, where you can able to predict your data by using some ML algorithms. So let's see in detail by using what services we can able to achieve these things in AWS. In AWS, how can we able to achieve these things? For storage, now I need to consider about the storage for data lake, right? Yeah. So in data lake, I want to store any type of data, that is I want to store any format of data. Either the data may be schema full or schema less. I want to store any size of data, that is large or small data. For these needs, I now I know one service. What is that? That is S3, where this S3 fits for the need of data lake, because S3 provides me unlimited amount of storage, as well as we can able to store any format of data in the S3, right? Yeah. So in S3 we can even manage or move data among multiple storage classes, and we can able to minimize the cost even in S3 by using S3 lifecycle management policies, right? Yeah. So that also I have written. So in the storage, I have written important points. That is for storage, what we are using S3 service for this data lake, and it can able to store unlimited amount of storage, and we can able to store any format of data, and we can able to manage data among multiple storage classes to minimize the cost by using what? S3 lifecycle management policy. So let's see the second option, that is data movement. So since we consider data lake as S3, here let's see S3 data movement options. We have multiple options available. We can manually upload our data directly to S3 from console, or we can able to automate the process. So to automate the process, we have multiple ways. I'll show you them. So you can use Snow family devices in order to migrate your data physically to S3 service, or you can say data lake, that you consider data lake. You have Snow family devices and direct connect, where it by using this direct connect you can able to provide a private network directly from your data center to AWS, and you can able to transfer your data to S3 directly. And you have database migration service as well to migrate your data from data your on-premise to AWS. And you have Kinesis as well. We even have this Kinesis. So don't worry, I'll tell you about this Kinesis, few more detail in upcoming videos. Okay. So now let's consider the another option, that is data catalog and discovery. To data present in data lake, it is best practice to provide metadata, because if a new employee try to understood this data without having metadata, is it difficult? Yes, it is difficult to understand. So the best practice is to maintain the metadata for the data lakes. So by using data catalog and discovery, we can able to provide metadata by using lambda functions. We can create automatic triggers for our lambda function to enter our data to enter some metadata about the data we uploaded to S3 bucket. So whenever we uploaded a file to S3 bucket, then we just triggering our lambda function. For what? To providing some metadata about the object that we uploaded under S3 bucket, and that metadata we are storing under any one of the storage service like DynamoDB we are storing. And if we want, we can able to analyze that data. We can even able to analyze that data present in DynamoDB by moving it to Elasticsearch. So here you need to remember few points for data catalog and discovery. The best practice is to maintain the metadata for your data lake data. So for that, one option is you can even create automatic lambda triggers whenever a data is uploaded to S3. Then whenever data uploaded or whenever a file uploaded to S3 bucket, we create a automatic lambda function where that will be triggered, and that lambda function will create some metadata and it will upload the data related to that file in DynamoDB. So in order to, if you want to analyze the data which is stored under DynamoDB, you have an option called Elasticsearch. You can move that data to Elasticsearch and you can able to analyze the data. So in order to perform this data catalog and discovery, we have one more option, that is AWS Glue. So by using this Glue, we are having data catalogs available in this Glue service, and Glue, Glue crawlers also available in that AWS Glue, so that we can able to process our data and query the data, and we can able to discover the results whatever we require. And the next one, that is generic analysis. Here you can see the generic analysis. Here we go through the insights of our data to get business success or failures related data. So here we analyze insights of our data to get analyze the business insights regarding failure or success of a company by using the data. So in order to do that, if we want to analyze real-time data like or managed stream of Kafka. So if we want to analyze data coming from Kinesis data streams or MSK, that is managed stream of Kafka, then we have data, Kinesis data analysis. So by using this service, you can able to analyze the data. Let's say if we want to process the data stored under S3, then we have an option called Athena service, Amazon Athena. By using SQL queries, we can able to process the data which is stored under S3. Let's say I have my data under data lake. I want to process that data. So for that, I want to process some structured data. For that, we are also having data warehouse service like Redshift. We can able to move our data to Redshift and we can able to query that data as well and store the results under S3 as well. If we want to create dashboards to analyze a more efficient way, we use dashboards, right? If you want to create dashboards from for some session of data, then we use this Amazon Quick Sites, right? Amazon Quick Sites is one more AWS service where we can able to use it for creating dashboards and analyzing them. So at last we have predictive analysis. What is this predictive analysis? So if you want to predict the future, if you want to predict the future by using the current data based on your business needs, you can move on with predictive analysis, right? Yes. For that, we use ML tools, machine learning tools providing services. In AWS, we are having AWS SageMaker. We can use that SageMaker in order to create a model or train a model and run that model in AWS. For all those things, ML based tool service we have in AWS is AWS SageMaker. By using that, we can able to create a model, train a model, and run that model in AWS. So additionally, for deep learning AMIs, we have pre-configured templates available. Those are TensorFlow, PyTorch, Apache MXNet, Casiner, Gluon, Harvard, and Kira. So these are the additional AMIs, deep learning AMIs. Those are already available in AWS where we can able to use them. For using these, we are not charged for anything. They're still pay as you go model on your instance basis. So this is about data handling in company. You got data from multiple places and you have two options to store your data. So in that we have seen data lake as we have seen what is the good data lake. For that we have even taken S3 as an example of data lake and we have analyzed the data with whatever the possible circumstances or possible needs which are by using real-time scenario. And we have also discussed whatever the AWS services that we use in this process. I hope you understood this video. I hope this video is contentful or you have some knowledge recap from this video. If you feel this video is contentful, then please like, share, subscribe and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye guys. Thanks for watching again.